Hello, my name is Morgan McLean. I'm a Director of Product Management at Splunk. I'm also one of the co-creators of the OpenTelemetry project, which I've been with since the beginning, and I'm excited to tell you more about it. So to begin, we're going to go through a journey of what's happened in the cloud and DevOps space over the last 10 or 15 years, and then we're going to talk about how we can improve everyone's management experience. So there's a lot of new technologies out, right, over the last 10 or 15 years. We have certainly things like Amazon Web Services, which mean that if we're managing high-scale services, we don't have to go build and manage our own data centers. Big improvement. And we also have platforms that allow us to scale a lot more easily, like Kubernetes and a number of other technologies on AWS and in other locations. These are generally excellent, and it is much easier to go launch your own web services company today than it has ever been in history. This is a generally good improvement. However, with all of these additional capabilities comes complexity. And the experience of managing an application at scale hasn't improved quite as much as the actual infrastructure and platforms that allow you to go and build and deploy these applications. And so I'm sure that many of you can agree, even if you're just using Amazon Web Services and you're using the technologies that Amazon provides, there's a lot of complexity, right? If you build enough services, if you rely on enough pieces of Amazon infrastructure, and you have a large enough team, knowledge is lost between those team members, and you don't always know how everything works in your application. This means that outages are more difficult to respond to, and it means that actual development is slowed down because people and your personnel lack the context on how things work. And this is just a very basic example. Certainly, as you expand and deploy tens or hundreds of services in AWS, you're going to expand to other locations, or you've actually come from other locations. For example, many companies that are on AWS also have existing legacy on-premises data centers that are still running production services. You may also have applications running in other clouds, so you may be in a hybrid cloud environment, and you're probably subscribing to a number of different SaaS services that interact with your application. On top of that, you have all the interactions that your customers take through web clients or iOS or Android or Windows or Mac clients, so that they can actually use and consume your services. With this, we build a very large web. And the challenge with this web is that basically no one understands the entirety of it. Yes, various engineers or ops personnel may have a very good idea of the services that they develop, and maybe they'll have a reasonably good understanding of the services or infrastructure that they directly interact with in addition to the ones they develop. But for example, if you're in this on-prem and AWS world, you probably have a lot of team members who don't know or have no context on what's actually running in the on-premises data center, even though through the chain they have production dependencies on it. You may even have things running in other clouds and not know about it, depending on your position within the company, and you probably don't know the full extent of the SaaS services that you use. This picture is quite worrying, I think, for a lot of technical decision makers as well as a lot of engineers, because if something goes wrong, they don't know how to fix it. Or if you're instructed to move things from on-prem to cloud, you lack the knowledge of what things to move and the interactions between these different services. This is the challenge, I think, that a lot of developers face and a lot of ops personnel face today. So the word observability has become quite popular in the industry the last few years, and it's good. Like, it's a generally good thing, but a lot of people have different interpretations of it. So a common thing you'll hear is the three pillars of observability are traces and metrics and logs. But this isn't a silver bullet. Simply having traces and metrics and logs isn't quite sufficient to filling in the different pieces of the puzzle, so you can get that full picture that I showed before of all of your services and all of your infrastructure. Rather, these are just pieces of that puzzle. So if observability is the picture, then you can use traces, you can use metrics, you can use logs, you can use profiles, network data, custom metrics, and many other types of information to fill in additional pieces of that puzzle. And the second half of that puzzle, which we're going to talk about at the end of this presentation, is how you analyze this data. So it's not just enough to capture the information, but you need to analyze it. So let's focus on the capturing. It turns out that this is actually a lot harder than most people appreciate. It sounds like it should be an easy step, but it's often not. And this is because if you're running in one of these large microservices environments across different cloud vendors and different pieces of infrastructure, you have many different dependencies. When I say dependencies, I'm not just talking about the dependencies within your service graph, but you have actual technical dependencies or different parts of your stack that are not consistent throughout your different deployments. For example, a lot of companies will be using a mix of Java, Go, Python, .NET, JavaScript, and other languages. Similarly, they'll be using the different platforms that I showed before, and also a mix of like Windows VMs, Linux VMs, Kubernetes, and other compute platforms, regardless of the cloud that they're running on. And then you also have a mix of different libraries and different RPC systems. So think of HTTP, gRPC. You might be using different storage clients for different databases, clients for direct AWS services, or message queues, or many other functions. And when we take the cross product between all of these, we end up with a very large set of code, of dependencies that we need to instrument if we want to gain that observability into all of our systems. Instrumenting these is really hard. You have to build integrations for each one. Every time one of the client libraries that you use gets updated or a language gets updated, you may need to go update that instrumentation in order to continue to have an observable system. This is incredibly difficult and incredibly expensive. And on top of this, you also need instrumentation for your prepackaged applications. Think of MySQL or Internet IIS or MongoDB, and other sort of software in a box, what do you pay for it as open source, that you deploy on your VMs and run there. So there's a ton of complexity here just for getting the data into a system so that you can then observe it. And this is where OpenTelemetry steps in. Throughout history, there's been many vendors in the space that have offered certainly different systems that allow you to observe your software as it's deployed and observe your infrastructure. But they've all faced challenges with capturing data from all of the different sources you need to pull information of, or at least capturing all of the different types of data that you need. This is what OpenTelemetry provides. It's a project that is strictly focused on capturing telemetry, capturing these signals from your infrastructure and from your applications, and then sending it to another location for analysis. Specifically, the project includes a few different things. The first and probably the most core is the OpenTelemetry specification. So these are definitions for traces and metrics and logs and soon other data types that we can use throughout the different components that I'm going to describe in a moment. Traces, this trace specification, indeed the trace instrumentation has already reached GA. Metrics will be coming out later this year. There's already prototype versions that some people are using. And logs is in an experimental phase arriving later this year or early next year. OpenTelemetry then takes these specifications and turns them into components that you can go and deploy. So it's not just a spec or interfaces, but it's actual code and artifacts that you can install on your systems. The first and probably the most well used is the SDKs. So we have SDKs for Java, Go, Python, JavaScript, Node, and a variety of other languages. And these SDKs will capture distributed traces from your services, and they're complete and full, and they include everything you need. So they'll capture incoming requests, propagate context internally correctly, and then correctly stamp outgoing requests with that context so that you can then trace a request as it goes across your systems. Similarly, once the metric specification is complete, they'll also include automatic metrics capture for all of your endpoints, any common libraries that you're using, as well as the ability to write custom metrics. Logs will also be coming to those SDKs. The next component that we have is the OpenTelemetry collector. This serves two purposes. So when we go back to the SDKs, you link an SDK to your application, and then you export the data. You can export this telemetry to a backend, like the various ones provided by Amazon or Splunk or others for processing, or you can export to the collector. So you can use the collector as an intermediary to capture the data from your application and then send it to its final destination for export. The collector can also be used as a traditional agent. And so in addition to processing OpenTelemetry data, it will also directly capture system metrics from your infrastructure on which it's deployed. So think of Kubernetes or AWS EC2 VMs. It can capture the relevant infrastructure metrics and metadata from them. And it will also eventually capture logs once that functionality is added. And again, that gets exported along with all of the other data from the collector. There's also some automatic instrumentation components. I'll talk about those in the demonstration a bit later. Those are an alternative to the SDK, so you can use one or the other or both. OpenTelemetry also defines protocols for each of these data types, which is the native way that the OpenTelemetry components use to communicate, to send traces, metrics, logs, and other data along. So I'm going to give a brief, before we dive into a real demo, I'm going to give a brief overview of how you could deploy and how you could use OpenTelemetry in a real scenario. So let's imagine that we have an AWS EC2 VM. And on our VM, we are running a JVM application written in Java and a MySQL database. And yes, typically you would not run both these things on the same VM, but this is a simple toy example that we can use. The JVM app communicates with other services that are perhaps running on EC2 or really anywhere else via gRPC, and it communicates with the MySQL database that's running on the same VM with a JDBC connector. First, we're going to deploy the OpenTelemetry collector. The collector is going to do a few things here. First off, it's going to capture system metrics from our EC2 host. In this case, I haven't written that on the slide, but it's a Linux host. Let's say it's running Ubuntu Linux. The OpenTelemetry collector will capture CPU consumption, memory consumption, disk consumption. The classic set of like 12 to 20 metrics that you would expect to capture from any kind of VM instance. Next, it will communicate with the Java virtual machine. And so it will capture, and this is if you include the correct integration, of course, but it will capture JVM, sort of core JVM metrics about like garbage collection, other core JVM tasks, and it'll send those along to your backend of choice. And similarly, it'll connect to the MySQL database and capture some relevant MySQL metrics. For the JVM and MySQL steps, you have to include the right integrations, but those are all included in the OpenTelemetry project. It's just that when you build the collector, you have to make sure that you include those specific integrations. However, this just gets us system metrics and some application metrics. I promised you a lot more than that earlier in this conversation. And so you'll also include the OpenTelemetry SDK. This will be linked. This is a Java SDK. It will be linked directly to your Java code. You'll rebuild and redeploy. And you can do two things with it. You can use the APIs natively if you wish to manually define traces and propagate context throughout the Java application. Most people won't do that, but if for whatever reason you want to do custom trace definitions, or if you want to create custom metrics, you can use the API yourself to do that. The other thing you can do is, as with the collector, include the appropriate instrumentation for the OpenTelemetry SDK for the Java frameworks that you're using, in this case gRPC and JDBC, and it will automatically capture incoming requests, ensure that it can generate a trace from these. It'll capture, once this is done, all of the appropriate latency metrics and other metrics for these, and it'll propagate the context and ensure that any outgoing calls, in this case responses back to gRPC, include the appropriate context object on them so you can get a trace through your entire system. In this case, we've configured the SDK to export the data to the collector, where it's eventually exported to our backend, whether that's CloudWatch or Splunk or elsewhere. You could, of course, if you so chose, just configure the SDK to directly export to a backend. If you're using a collector already to capture system metrics, not much reason to do that. As an alternative to the SDK, you could also use, depending on the language, one of our automatic instrumentation packages. Java is supported by this, so we can use the OpenTelemetry Java instrumentation package. And in this case, instead of linking an SDK to our application and rebuilding and redeploy it, we've instead included this package, referenced that with the JVM, and it will go look at our Java code and find any gRPC calls and JDBC calls and instrument those with traces. This is often much easier to get started with, and certainly for enterprises where rebuilding and redeploying an application just to include instrumentation is challenging, this is a good alternative. The cost of doing this is that you don't get access to the native SDKs, so you can't go define a custom metric, you can't go create custom spans for your traces. To do so, you would need to use the Java SDK. You can, though, use both of these together. If you wish, you can use the Java SDK, just don't export any data, and the OpenTelemetry Java instrumentation package will see any calls within the SDK and pick those up as well, along with everything else that it was already picking up. Finally, we have a choice of how we want to download these components. So probably the most popular is the core OpenTelemetry repositories. OpenTelemetry is a batteries included project. Again, the SDKs are fully featured, and as is the collector. And so that's probably the most common way to download these components, particularly for the SDKs, because a lot of developers like to just get the same common set. And you can do this. Like the other distributions I'm going to talk about in a minute, they don't include anything that's special, anything that you can't get in the pure open source project. They're just sort of repackagings of it. And so you don't lose anything by just using the pure open source distribution. And that's a core tenet of the project. We're not going to move away from that. The cost of using the main distribution, the reason it's not the most popular is, or rather, the reason it's not just the default choice for everyone is twofold. First off, distributions are typically created to have paid support plans for them. Very few vendors are willing to support a pure open source distribution because they can't patch it quickly and then upstream their patches. And secondly, at times, vendors like to include other open source components, typically from OpenTelemetry, but sometimes from some other solutions, just to package those up and send them to you. So an example is the AWS distribution. It only includes pure OpenTelemetry components, but it includes specifically the ones that you need to pull data in from AWS. So if you use the AWS distribution, you no longer have to go ensure that you have the right AWS packages linked to the core one. Those are included out of the box. That means that you can capture the right AWS metadata. That means that you can export the data to backends like AWS CloudWatch, AWS X-Ray, Splunk, and others without having to just go manually include those components, even though they're from the OpenTelemetry distribution. Similarly, Splunk has its own distribution, as do many other vendors. The Splunk distribution is almost pure upstream, just like AWS. However, it has paid support from Splunk. If you're a Splunk customer, this is very useful to you. And secondly, it includes FluentD for logs. But going back to what I mentioned about the core tenet for the project, as soon as OpenTelemetry, as soon as the collector has logging support built in, which we're working on right now, then we'll be replacing FluentD with that. It'll be a pure upstream distribution that just happens to have paid support from Splunk. So now we're going to dive into two hands-on demos. The first one is a very basic, very simple demo that demonstrates how easy it is to get started with OpenTelemetry. So I have a very simple JavaScript HTTP server and HTTP client application, and I'm going to instrument these manually with OpenTelemetry. Again, I could also pull in the automatic instrumentation for JavaScript, either the correct instrumentation for the SDK or the automatic instrumentation package, and it would do this with just a few lines of code or a few clicks. But I want to show in the manual cases where as a developer, where you want to go create your own spans or define your own custom metrics, how easy it is to get started with our APIs. So let's dive into that. So this is our Java HTTP server. We've gone and instrumented it with OpenTelemetry. I've done this by requiring the OpenTelemetry SDK here. That's included our JavaScript SDK. And I've also defined a tracer object that we can use down below. Now, as an alternative, we could have included one additional piece, and that would be the automatic HTTP instrumentation for OpenTelemetry. That would automatically capture, spans, and propagate context for any HTTP requests that propagate through our server. I haven't done that here just so we can get a better understanding of how we can use the APIs manually. So if we scroll down here, we can see how we handle requests within the server. And you can see here where we define a span, this is a component for trace, for every request that comes in. Again, if you use the automatic instrumentation or rather the SDK's HTTP library, you don't need to define this manually, but you can do so if you like. The reason I did this is you can actually see how we create a custom span. So if we have a business process or some long-running process in the service that we think needs to be shown on every trace as an additional span, we can do that with the SDK. And so in this case, we've added an additional event on every request that shows that we're invoking handle request, and then we run a fake long-running process. And so when we jump back to the view of our when we jump back to the view of the trace that's generated by this, then we can go see that. So let's take a look. And here we can see the results of our capturing the HTTP requests through that HTTP server, as well as how we captured that long-running process that I showed where we created the custom span. This is an example of Jaeger. Of course, you could also send this data to Zipkin or AWS X-Ray or Splunk or like dozens of other sources. But when you look at a basic trace view, a lot of them will present something like this, and we can see how the two spans were captured from the server on every one of these interactions. So now I'm going to show something a little more advanced. What I've done is gone and instrumented the online boutique, often called Hipster Shop demo application from Google. We've got this running in a number of AWS EC2 instances. I think I've actually deployed it on EKS. And I've gone and instrumented each of the services that this demo includes. For those who aren't aware, Online Boutique is a mock e-commerce application. It includes, I think, 12 or 20 or so services written in a variety of different languages. It uses many different storage technologies. It's a really great test bed for microservices applications, and that's why we're using it here. I'm going to not dive too deeply into the instrumentation of this, just because in most cases we've done it automatically without a whole lot of work. But I'm going to show you with an analysis system like Splunk Observability Cloud, the data and the insights that you can generate from this. So now that we've captured this data from our environment with OpenTelemetry, let's see what we can do with it. I've entered Splunk Observability Cloud. This is our APM view within Observability Cloud. We have similar views for infrastructure and logs and other types of data. And what we're seeing here is an overview of all of the services in this Hipster Shop deployment. So we're going to start with this automatically generated dashboard, and then we'll show the actual connections and context between these services. So this is probably what you'd expect from most APM products. We have a list of your top services by error rate, latency, your top business workflows. Think of like gRPC operations, HTTP endpoints by error rate, and top by latency. You can also dive deeply into particular services and get a more detailed breakdown of their latency requests and errors. And if you click here, you can go even deeper. But what I want to show is the context. This is what I talked about earlier in our discussion. I want to show that overall view of all of my services, their current status, and how they interact. Because if I'm a developer or ops person, not only do I want to know if the services that I care about are performing as expected, but I also want to understand their context and their place within our broader application. So I'm going to go to our larger dependency map. This shows the entire Hipstershop deployment and how each service in that deployment interacts. I can see the front-end service, how it calls down to recommendations, how that calls down to product catalogs, and all the dependencies of all the different services here. Similarly, I can understand the interactions just between a particular set of services. So if I want to learn more about the interactions between the front-end service and the cart service, I can simply mouse over here. And if I want to learn more about the errors or something occurring within a particular service, such as the product catalog service, I can click on it and be shown more data. Similarly, if I want to view have an even deeper view into this particular service, I can view one of our automatically generated service dashboards that give me the essential metrics like request rate, request latency, and error rate for this service over time. This can also be correlated with host metrics. Those are shown down below. But this map is useful in a number of different scenarios, right? If we think of core development, this lets us understand how one of our services or a proposed new addition would interact with the rest of the topology. And if I had a larger deployment, this map would simply scale out to show it. This can replace the expert in the room that so many organizations have, where they have one person who comes in who understands most of the topology. You can draw it on a whiteboard. And on top of that, it actually shows you the error rate and latency and different connections between these services. Super powerful stuff. Now, this is, I think, a great demonstration of the power that you can get from OpenTelemetry and observability if you're an application developer. But there are similar requirements for ops personnel or anyone who has a more infrastructure-centric view. And OpenTelemetry is not just limited to this application view. It can also inspect infrastructure as well. So in Observability Cloud, I'm going to go to our infrastructure browser. And here I can see the various different cloud services that we've instrumented with OpenTelemetry across different cloud platforms, and I can dive into those. I'm going to jump into EC2. So we've a set of 6 EC2 VMs here that we've instrumented with the OpenTelemetry collector. They're running the components of the Hipstershop service that you just saw. And with the data that comes in from that, we've actually gone and built a dashboard that covers all of these EC2 services. And similarly, I can dive into a particular host and get an even deeper view into what's happening on that host. This is all, again, powered by OpenTelemetry, powered by the exact same data that we saw before. This is just a more infrastructure-centric view of that data coming from the application. And indeed, we can actually jump between this view of this EC2 instance and of the applications that are running on top of it. That would take us back to a sort of a more constrained view that we saw in the APM visualization a few minutes ago. So there you have it. We've seen demonstrations of OpenTelemetry and certainly a long discussion about its value and how easy it is to use. And I've shown you how easy it is to start with in a toy JavaScript demonstration, as well as how OpenTelemetry can be used in production with a backend like Splunk Observability Cloud to extract meaningful insights and context and just improve your general development experience for a workload like the Hipstershop demo, which is probably similar to the workloads that a lot of the attendees of this talk are familiar with. Okay, and that wraps up our demos. So I've said my bit about OpenTelemetry, and I've shown you both how easy it is to get started with, and I've also shown the power of the data that you can capture with OpenTelemetry when you tie it into a incredibly deep and powerful observability system. But I still want to talk about a few more things. The first is our community. So OpenTelemetry has been growing like crazy since we launched it about 1.5 years ago. It is now the second largest project in the Cloud Native Computing Foundation after Kubernetes, which is a fact we're incredibly proud of, and I never would have imagined we would have found this success when we launched it. So I think that definitely speaks to the usefulness of this data and to the challenges that a lot of developers have had with getting really great observability throughout their systems. So if you want to join the community, there's many different ways to do so. The first thing I'd recommend is going to our website. That's opentelemetry.io. You can also find us on GitHub at github.com/open-telemetry. If you go to our GitHub pages and you're in the organization for the first time, I definitely recommend visiting the community repository. It has links to our weekly meetings, as well as links to the every other resource you need to get connected to the community. The next is our Slack channel. So we're on CNCF Slack. We used to be on Gitter. I think there's still a few SIGs are still on Gitter, but almost everything else is migrated to the CNCF Slack instance. You can find us there under the OpenTelemetry channel, and then each of our special interest groups within OpenTelemetry have their own channels beneath that. So yeah, many different ways to get involved. We are itching to get even more people in the community. Whether you are an end user developer, whether you are a vendor in the space, or you work at a cloud provider, there's always a place for you. We're excited to take in new voices and gain new contributions. If you're looking to really do some heavy lifting, I recommend joining our weekly SIG meetings. So the project is broken apart across different what we call special interest groups. We have one for each language. We also have the core maintainer SIG as well as a SIG for the collector. So please, if you're looking to really make some larger contributions and you want to meet the people you'll be working with, certainly join our Slack channel, but show up to the community meetings. And to do so, just open up the calendar that's linked to on our community GitHub page. Finally, I want to thank you for attending this session. So we're always excited to talk about OpenTelemetry, whether it's myself or any of other a large number of community members. We do tons of talks on this, and we're always excited to bring in more people. You can find me on LinkedIn. You can my LinkedIn address is listed below. And if you have any other way to contact me, you can find me on GitHub or on the CNCF Slack or many other places. Happy to chat with anyone, as are so many of our other community members from all of the different companies and organizations that contribute to OpenTelemetry. So thank you very much. Definitely complete the session survey. Happy to get your feedback and find out more and find out if OpenTelemetry is useful for you. And that wraps it up. So thank you very much. Have a great day.